Hello again, this is section 2. We want to begin nomenclature of carboxylic acids. That is to say, we want to name the carboxylic acids. Now, when you name carboxylic acids, that's the first step for naming the carboxylic acid derivatives. Here, the textbook just focuses on naming carboxylic acids. Some textbooks jump right in and they start naming esters, amides, acid chlorides, anhydrides, and all of the derivatives, and it can be kind of overwhelming. I like how the book separates the nomenclature and they talk about naming of the acid chlorides, for example, when they get to that section. But here I just want to give you an overview. As usual, you find the longest chain, and that might be highlighted in green here. So 4 carbons is butane, right? And there's a carboxylic acid functional group. Now, what you need to do is modify the ending. So you chop off the E, right? This is not an alkane, it's an carboxylic acid. So the ending of the name becomes oic acid. So all of your carboxylic acids are going to end with oic acid, all right? And there's a little space between the C and the A there, right here, okay? And if you have a carboxylic acid derivative, you basically want to chop off the ic acid part and then add YL chloride if it's an acid chloride, or you'll add O8 or O-amide or something like that if it's an ester or an amide, okay? So anyway, we're just going to focus on this part of the naming, all right? We're going to find the longest chain, we're going to number it, and then we're going to figure out how many carbons there are. And keep in mind that a carboxylic acid is always going to be carbon number 1. Okay, the CO2H moiety is always carbon number 1 because you can't have a carboxylic acid group in the middle of a chain, right? You can't have 5 bonds to carbon, so you're never going to have a carboxylic acid at carbon 3. You're always going to have a carboxylic acid at carbon 1. And it doesn't matter if the carboxylic acid is written this way or this way. The carboxylic acid will always be carbon 1, and all of those are just called butanoic acid. We don't need to say 1-butanoic acid, all right? Let's get into some nomenclature. So once again, if you have a ring, okay, we have memorized that this guy here is called benzoic acid. And that name needs to be memorized. There's no way to IUPAC designate that, okay? We have some other common acids, which are formic acid. Formic acid is produced by ants and other insects, and so if a fire ant stings you, it's actually injecting formic acid into your skin, okay? And that's, of course, causing the irritation. Acetic acid, we've talked about before, is very commonly just called acetic acid. We could call it ethanoic acid, but that would be more confusing than just calling it acetic acid, okay? And then from this point on, everything becomes systematic, okay? Propanoic, butanoic, pentanoic, you know, hexanoic for 6 carbons, octanoic for 8 carbons, or even decanoic for 10 carbons, okay? Now, another weird kind of naming system is when you have a ring like this, and then you have a carboxylic acid hanging off of that, okay? So it's hard to identify where the longest chain is. You would ideally want the longest chain to include that carboxylic acid, but the ring is 5 carbons, which is greater than that. So how do you name this? You name this cyclopentane for the 5-membered ring, and then you add carboxylic acid, okay? So it's called cyclopentane because it's 5 carbons, okay? And then you just add carboxylic acid to it. Okay, cyclopentane carboxylic acid. So that's how you would name something like that. Now, something else that the textbook gets into is naming biologically relevant dioic acids. So for example, if you have something like this, many of these carboxylic acids are produced by bacteria and fungi and things like that. And so they have biological names that predated the IUPAC designations. So you have weird things like oxalic acid, malonic acid, succinic acid, and glutaric acid. I'm not a fan of making students memorize biology names for these carboxylic acids. So let's name this by IUPAC. This is 5 carbons, so we would call it pentane, okay? And we would call this pentane dioic acid, okay? Pentane dioic acid, okay? We don't need to say 1,5 dioic acid because there's, of course, the carboxylic acid must be at the ends of the 2 chains, okay? You can't really have 3 carboxylic acids. Something like citric acid does have 3 carboxylic acids, but it's a branching off of carbon 3 of this molecule here. So anyway, that's as difficult as it really gets. Let's do a practice problem here. Okay, so this is problem 21.1, and we just need to name it. My questions will always just ask students to provide an acceptable name. If they do it with IUPAC, great. If they're a biology student or really going on to medical school and they memorized all of the biological names for these, that would be fine too. So just provide a name. So keep in mind that the carboxylic acid group is sometimes written as CO2H, okay? And we've already named this one here. So this guy here has 5 total carbons. And we called that pentane dioic acid. Okay, so there's no numbering necessary there. In part B, we might sketch this out just to see a bond line sketch of this. So we've got a total of 1 plus 2 plus 1 for the carboxylic acid, so that's a total of 4 carbons. So it's easier to see in this drawing that it's just butanoic acid. In part C, we have C6H5. That is a phenyl group, okay? C6H5 could be abbreviated PH. It could be drawn as a phenyl. Phenyl is like this with something attached to it. And so that's a carboxylic acid group, a CO2H, and we call this benzoic acid, okay? So again, we're just dealing with the basics here. It doesn't need to be too complicated. Here in part D, what do we have? We have a total of 2 carbons in the middle, 4 carbons. So this is going to be butane dioic acid. So it's going to look just like part A, except have 1 fewer carbons. And so I have not memorized the biological names for these, but I would call this butane dioic acid. Okay. Next in E, we have this guy here. Probably don't even need to draw it out. That's 2 carbons. It's easier for me to name this as acetic acid. Okay. You probably have memorized that formula in general chemistry. Now keep in mind that the carboxylic acid functional groups can be written as CO2H in many of these problems or COOH, okay? Nobody's trying to trick you. There's just different ways of typing it out on a Microsoft Word or word processing software. In F, I would call this formic acid. Okay, 1 carbon. You could call it methanoic acid if you really wanted to. If you didn't remember, that's called formic acid. Okay, but yeah, that's formic acid, okay? let's do another problem. Looks like problem 21.3 is good. Let's do this one. All right, so here are some interesting carboxylic acids. So when you have something with methyl groups or other substituents, you want to identify the longest chain that definitely includes the carboxylic acid, just like we did with aldehydes, okay? So your aldehyde is always going to be carbon 1. Your carboxylic acid is always going to be carbon 1 because that's the important functional group. A methyl group is just a substituent. It's not a functional group. So we want to number the longest chain that we find, starting with carbon 1 at the carboxylic acid, no matter what else you find in your molecule. And so here we have 2 methyl groups at carbon 3 and 2 methyl groups at carbon 4 for a total of 4. So this is going to be a tetramethyl, okay? Now remember, you need a number for every single methyl group. So we need to do 3, 3, 4, 4, and then write in tetramethyl. Okay, 6 carbons is hexane. We drop the E at the end and we add oic acid. So this is going to be hexanoic acid. And we leave a little space here before we write the word acid. Okay? So hyphens between numbers and letters, commas between numbers, and we leave a space here between the end of the name and the first part of the acid, okay? Now, remember what I said. You number the longest chain starting with the carboxylic acid. If you number the longest chain, you could do it to the left or the right because they're both 5 carbons in length. So this is going to be a pentanoic derivative. This guy right here is 3 carbons. We call that a propyl group. So the name of molecule B is going to be 2-propyl. Okay? And then we just want to stick on there pentanoic acid. The important part, of course, is in green, pentanoic acid. Letter C, this is phenylalanine. This is one of the amino acids that are naturally occurring out there in plants and animals and even in your body right now. So we want to, once again, there's some complicated stuff in here, but first identify your longest chain. So there's carbon 1, there's carbon 2, and there's carbon 3. So this is 3 carbons long, so it's a propanoic derivative. And then we have some substituents here that might look a little weird at first, but this guy right here is called a phenyl group, okay, phenyl. And this guy right here is called an amino group, okay? And that's where the term amino acid came from. This is an amino group and it's a carboxylic acid, so they call these amino acids. So the name of this complicated looking guy would be, we want to abbreviate it, right? So phenyl and amino. Amino is going to come first. So we have 2-amino. Okay? And we have 3-phenyl. And then we want to add propanoic acid to the name. Okay, so I won't do a whole lot of other problems. I think you kind of get the idea for how to name carboxylic acids. Thanks for watching and check out my other videos.